Let's now talk about mutable arguments. If you want to define an fn function and want an argument to be mutable, in simple words, argument inside the function are visible outside the function. Declare the argument as mutable with the inout keyword. Please pause the video and take a look at the given example. Now we will try to run the code in MOJO Jupyter Notebook to see the output response. You can find the Jupyter Notebook console in the video description. After we execute the code, we observe error. Why? Let's go through the code closely and understand the code explanation. Explanation. The code is trying to add two integers together. The first integer is self and the second integer is RHS. In order to do this, it uses a function called _add_, which takes in self and RHS as arguments. This function returns an integer that will be assigned back into self for use in the next iteration of the loop. The code also has a function called _iadd_, which takes in two integers as arguments, self and RHS. This function does not have any return value because it cannot assign anything back into itself since it's immutable, self equals self plus RHS. The code attempts to show that the self and RHS variables are immutable in _add_. The code above does not work for _iadd_ because it cannot assign to self. Discussing the code example further, the problem here is that self is immutable because this is a MOJO fn function. The solution is to declare that the argument is mutable by adding the inout keyword on the self argument name. Please go through the sample code. Let's discuss code example further. From the code syntax you can understand that self argument is mutable in the function and any changes are visible in the caller, even if the caller has a non-trivial computation to access it, like an array subscript. Let's see a code example in detail. Please pause the video and try to go through the code example. Now let's see the explanation. Explanation. The code starts by creating a variable x with the value 42. The code then adds 1 to x, which makes it 43. Next, the code prints out the value of x and shows that it is now 43. Then, in line 3, we see that a new variable called y is created and initialized with the value of x, 42. In line 4, we see that y is incremented by 1 making it 43 as well. Finally in line 5 an error occurs because you cannot mutate let values. The code will print the value of x, which is 43. The code will print the value of a 4, which is 8. Let's move further. MOJO implements the in-place mutation of the above inline fixed vector element by emitting a call to _getItem_ into a temporary buffer, followed by a store with _setItem_ after the call. Mutation of the let value fails because it isn't possible to form a mutable reference to an immutable value. Similarly, the compiler rejects attempts to use a subscript with an inout argument if it implements _getItem_ but not _setItem_. Let's see about swap functionality with code example and explanation. Please go through the code syntax and try to understand the logic. Let's see the explanation. The code has a function called show_swap that takes two arguments, x and y. The first argument is an integer variable named x and the second argument is an integer variable named y. Inside of the function, there are 3 lines of code, var x equals 42 var y equals 12 swap x, y, print x hash prints 12. The code will swap the value of x and y. The output of this code is 1242.